Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible.
Hello friends, in this video we will study about brick manufacturing, properties, classification, sizes, brick bonds, uses. The history of professional construction practices. Brick is one of the oldest of all building materials. It is also arguably the most durable, since there are brick walls, foundations, pillars, and road surfaces constructed thousands of years ago that are still intact. Today, bricks are most often used for wall construction, especially as an ornamental outer wall surface. Brick definition. A brick is building material used to make walls, pavements, and other elements in masonry construction. Traditionally, the term brick referred to a it composed of clay, but it is now used to denote rectangular units made of clay-bearing soil, sand, and lime, or concrete materials. Typically, bricks are about 4 wide, 8 inches long, with a variety of thicknesses. Larger stone or clay-based building units of the type used in foundations are usually called blocks. Bricks are small rectangular blocks that can be used to form parts of buildings, typically walls. Bricks are still in common use today for the construction of walls and paving, and for more complex features such as columns, arches, fireplaces, and chimneys. They remain popular because they are relatively small and easy to handle, can be extremely strong in compression, are durable and low maintenance. They can be built up into complex shapes and can be visually attractive. Site selection for manufacturing of bricks. For the manufacturing of bricks, the site should be selected based on some important considerations such as: the ground should be of plain surface. The site should be connected with communicating roads for transporting materials, etc. Good brick earth should be easily available. The site should offer all facilities to the workers. Manufacturing of brick. Manufacturing of brick. Raw materials. Clay is one of the most abundant natural mineral materials on Earth. For brick manufacturing, clay must possess some specific properties and characteristics. Such clays must have plasticity, which permits them to be shaped or molded when mixed with water. They must have sufficient wet and air-dried strength to maintain their shape after forming. Also, when subjected to appropriate temperatures, the clay particles must fuse together. Types of clay. Surface clays. Shales. Fire clays. Diagram showing process of brick making. Types of clay. Clays occur in 3 principal forms, all of which have similar chemical compositions but different physical characteristics. Surface clays. Surface clays may be the upthrusts of older deposits or of more recent sedimentary formations. As the name implies, they are found near the surface of the earth. Shales. Shales are clays that have been subjected to high pressures until they have nearly hardened into slate. Fire clays. Fire clays are usually mined at deeper levels than other clays and have refractory qualities. Surface and fire clays have a different physical structure from shales but are similar in chemical composition. All three types of clay are composed of silica and alumina with varying amounts of metallic oxides. Metallic oxides act as fluxes promoting fusion of the particles at lower temperatures. Metallic oxides, particularly those of iron, magnesium, and calcium, influence the color of the fired brick. The manufacturer minimizes variations in chemical composition and physical properties by mixing clays from different sources and different locations in the pit. Chemical composition varies within the pit, and the differences are compensated for by varying manufacturing processes. As air salt, brick from the same manufacturer will have slightly different properties in subsequent production runs. Further, brick from different manufacturers that have the same appearance may differ in other properties. Steps involved in brick manufacturing. The process of manufacturing of bricks is carried out in a number of stages. These are listed below. Each stage has its own specific importance. Stage 1. Selection of the suitable type of brick earth. Stage 2. Preparation and tempering of mud. Stage 3. Shaping or molding of brick units. Stage 4. Drying of molded bricks. Stage 5. Cooling and burning of bricks. Stage 1. Selection of the suitable type of brick earth. Good quality building bricks cannot be made from every type of earth or soil. As a general statement, it may be said that any soil, earth, which contains 4 parts of clay and 1 part of sand is suitable for making bricks. This is, however, a general statement. A suitable earth should have various constituents in the following proportions. Alumina, 20 to 30%. All clays are basically hydrous aluminum silicates. Clays are responsible for the plastic character of the mud. If they are present in higher proportions, the brick will shrink on drying, and develop cracks. If they are present in smaller proportions, the brick will not be molded easily and nicely. The above percentage of alumina, 20 to 30%, imparts the brick sufficient plasticity. Silica, 50 to 60%. This is present in 2 forms, the silica combined as a constituent of clay, and the free silica, sand or quartz. The total proportion of silica should form about 50 to 60%. It is why the actual clay content and free sand content has to be broadly in the ratio of 4:1 in the good brick earth. Silica is responsible for strength, hardness, and resistance to shrinkage and shape of the brick, and, also to a great extent, for its durability or long life. but if we add too much free sand in the brick earth and thereby raise the proportion of total silica in the earth, resulting bricks would be very brittle and porous and may not burn easily. Lime, 4%. This component makes burning and hardening of bricks quicker and therefore is considered desirable with following two conditions. It would not be more than 4% because in that case, it may cause excessive softening of bricks on heating. Lime and magnesia act as fluxes. It must be present only in a finely powdered and thoroughly dispersed form. Otherwise, if present in small grains or nodules, the lime itself will get slaked, heated, and once the brick is used, lime, will easily get hydrated and cause disintegration of brick. Magnesia, which is invariably associated with lime, also has a similar effect. It is their total percentage which must be considered while determining the composition of the brick earth. Iron oxide, 4 to 6%. Like oxides of calcium and magnesium, iron oxide also acts as a flux, i.e. it lowers down the softening temperature of silica. The iron oxide has, in addition, another important function: it imparts the red color to the bricks. The excess of this oxide will make the bricks too soft during burning, where there is a risk of deformation, besides making them darker in appearance. A shortage of iron oxides in the earth will affect the final color of the bricks. Instead of being brick red, they may be yellow or light red. The yellow color may also be due to incomplete burning of bricks. Besides the above desired essential constituents of good brick earth, there are some materials which should not be present in the good quality brick earth at all, even in a small percentage. There are some harmful effects of shortage of iron oxides. Lime nodules. Free lime nodules will hinder improper burning. They will also adversely affect the quality of final brick. Organic matter. This includes roots of grasses, leaves and other vegetable matter. Such matter will affect the quality of brick if left incompletely burnt during the process. Sulfides and sulfates. Iron sulfide in the form of pyrite and alkalis in the form of potash and soda are some other common impurities present in many soils. The effect of iron sulfide is that it creates disintegration or cracking in the brick during the burning stage. In the case of alkalis, besides their pronounced flux action similar to lime and magnesia, they are liable to stay back in the final brick. When such a brick is used in a building, the alkalis absorb moisture from the atmosphere very easily. They get dissolved into it, and when this water is evaporated from the surface, they reappear in the form of scum or encrustation or patches of white salt. This phenomenon is called efflorescence. Is a common cause of disfiguration of such a brickwork made from alkaline soils. Summarizing, the ideal composition of a good brick earth is: clay 20 to 30%, silica, total, free, and combined 50 to 60%, CaOMgO 4 to 5%. Iron oxide -4 to 6%. The earth should be free from alkalis, organic matter, free lime, and organic matters as far as possible. So the above is the first step of bricks manufacturing. Field tests for brick earth. When amateur brick making unit is to be established, it is always advisable to go for a thorough survey of the brick earth deposits. That will include mapping their area and volume and carrying out their chemical analysis. The first step will assure the total quantity of the brick earth available, and the second, its quality. Test for the consistency of soil. Test for determining molding properties. Test to determine deformation on burning. Strength tests. Test for the consistency of soil. Small balls are made from the soil by mixing with appropriate quantities of sand and water. These balls are allowed to dry in a shaded place. When completely dried, they are studied for any deformation in their size and shape, and appearance of cracks. When the soil is of a suitable type, the balls should show no cracks or shrinkage effect. If shrinkage effects are observed, new balls are made by adding more clay or more sand or adjusting quantities of water. This is done to see if the soil properties can be improved by adjusting the main components, clay, sand, and water. By trials, a right proportion of the constituents may be found which will make a good quality of earth for the manufacturing of bricks. In case all trials give same negative results, then the clays are not suitable for manufacture of bricks. Test for determining molding properties. This test is usually carried out on the soil that has passed the first, consistency, test. The soil is kneaded very thoroughly in the presence of some additional quantity of water. A homogeneous mud is thus made ready. From this mud, thin threads, about 3 to 4 mm thick, are made by rolling between the palms of two hands. If thin threads can be rolled and these do not break on acquiring good length, it shows the clay is of good plastic nature. Otherwise, threads will break on rolling to small thickness. From the mud so prepared, test bricks are made and allowed to dry. If their corners and edges are well formed, the soil is assumed to possess satisfactory molding properties. Such shapes must be retained by the test bricks even on drying. Test to determine deformation on burning. Presence of fluxes in greater or lesser proportion cannot be tested by the first two tests. So, it is essential to subject the bricks made from the above soil to burning test. Such bricks should be, of course, properly dried before doing so. These dried test bricks are burnt in a potter's kiln for 3 to 5 days. If after burning and subsequent cooling, the bricks retain the uniform shape and develop the brick red color and have a good appearance, The earth is said to have passed this test also for the manufacturing bricks process. If, on the other hand, the bricks show on burning some typical defects like warping, twisting at edges or corners, swelling on surfaces, then, the soil composition is defective with respect to one or another of the essential ingredients. The soil may not be suitable for manufacturing of bricks of good quality without proper investigations and treatment. Strength tests. These tests are carried out on a series of test bricks made from the soil as above and which has already passed all the 3 tests. These tests can be carried out approximately in the field, or, even in the laboratories. The test involves dropping the bricks, one by one, from a height of 2 to 3 meters on a hard dry ground below. Good quality bricks should easily withstand this shock without breaking. For the laboratory testing, the test specimens are subjected to routine testing in a well-equipped civil engineering laboratory for compressive strength, bending strength, and water absorption. These tests will be discussed below. Stage 2. Preparation and tempering of mud. A series of steps are necessary before the earth is ready for molding of bricks. The area selected for the brick earth is first cleaned or unsoiled at the top. This is necessary to remove most of the undesirable topsoil, which is always rich in pebbles and organic matters. From this cleared area, brick earth is obtained by surface digging, by using hand tools. This is the most common method followed in most countries. Mechanical excavation, by using heavy machines called excavators. This method is applied to large-scale mechanized brick making and especially when the earth is hard and compacted. Cont. After the removal of soil, the clay is spread in heaps and layers over the ground for weathering or seasoning. During this period, it is also cleared of any pebbles, stones and lime nodules. Moreover, any clay lumps are broken into a fine powder so that a uniform-sized seasoned earth is prepared. It is at this stage of seasoning or weathering that any additional component, sand clay, is mixed with the brick earth to alter its composition to any desired degree. The seasoned clay is said to be ready for conversion to mud by mixing with appropriate quantities of clean water. These operations of selecting the earth, clearing, and digging it, spreading it for weathering are together called as winning of clays. Tempering. Tempering means converting of the prepared brick earth into a homogeneous mix of the desired plasticity by mixing it thoroughly with proper quantities of water. This is done either by manual labor or with the help of a specially designed, mechanical device called pug mill. In manual tempering, the clay is thoroughly kneaded under feet, of either men or cattle, with gradual additions of water till desired homogeneity and plasticity are obtained. Stage 3. Moulding of bricks. Moulding is the process of making properly shaped brick units from a thoroughly tempered clay. There are 2 main methods of moulding. Hand moulding, when the job is done by skilled persons. Machine molding, when specially designed machines are used for molding of bricks. In most countries, even today, the most common method of molding of bricks are hand molding. In the advanced countries, however, mechanized brick making is the main process for large-scale manufacture of bricks. Hand molding of bricks. In hand molding, the quality of the tempered clay is invariably soft, so that it can be molded into the required shapes conveniently. The mud contains more water, 18 to 25% by weight, than what is used when machine molding is to be done. It is for this reason that this method is sometimes referred as soft mud process. Bricks are shaped from such a soft mud by hand either on a specially prepared ground, called ground molding, or on special tables, called table molding. Tools. The essential tools used in the hand molding process are a brick mold, cutting wire or strike, wooden plates called pallets, and a stock board. The mold is made either of wood or steel. Its inside dimensions are slightly bigger, about 1/10, than the desired dimensions of dry bricks, because bricks will shrink on drying due to loss of moisture. It may be a single unit mold or a multiple unit mold. The stock board, also called molding block, is a small wooden block, slightly bigger in dimensions than the mold and with a raised central projection carrying the identification mark, frog. The pallets are thin wooden plates for handling green bricks. The strike, made up of wood or metal, has its one edge quite thin to slash surplus mud. Cutting wire is meant for the same use. Types of hand molding of bricks. There are two types of molding used in the manufacturing of bricks. Ground molding. Table molding. Ground molding. At present, this is the most common method of molding of bricks in most countries. In this process, a piece of land, the ground, is first cleaned, then thoroughly leveled and often made smooth by plastering. Some sand is sprinkled uniformly over it to make it non-sticky. There are two variations of ground molding. For making ordinary rough-faced bricks. For making smooth-sided, frogged bricks. For making ordinary, rough-faced bricks without any frog or identification marks on them. The mold is either first dipped in water, slop molding, or some sand is sprinkled on its inside surfaces. Sand molding. This step is necessary to avoid sticking of the mud to the sides of the mold. Then, the mold is placed on the ground. A lump of mud is dashed into the mold by hand. Care is taken to see that mud reaches the edges and corners of the mold. Any surplus mud is then removed by using either the strike or the cutting wire. After this, the mold is lifted up with a jerk. The molded brick is left behind on the ground. The molder then keeps the mold at the next place. The molder repeats this process. The face of the brick which rests on the ground will be naturally rough and without any identification mark. For making smooth-sided, frogged bricks. This requires a stock board and pallets. The stock board has erased projection, 6 mm, carrying impressions or marks of the manufacturer carved out in it. For molding of bricks using the stock board, the mold is, as usual, either first dipped into a bucket of water, slop molding, or, some sand is sprinkled on its inner sides, sand molding. This mold is then placed on the stock board with projection in the center and a lump of prepared clay is dashed into it. Any surplus mud is removed by using the strike or cutting wire. Appellate is then placed on the top of the mold and the stock board is turned over. Thereafter, the mold is lifted up, leaving the molded brick on the pallet below. Another pallet is placed on the upper surface of the green brick and it is taken to the drying field, where it is placed first on its edges to dry. The pallets are thus available for use again and again. This process, where pallets and stock board are used, is called rightly pallet molding. Table molding. It is also a type of hand molding method. The molder carries out all the operations of pallet molding on a table of suitable dimensions and while in a standing position. Such a table is large enough to accommodate all the materials required in the hand molding, namely, a stock board, molds, cutting-edge bucket full of water or sand and supply of tempered mud. The process is similar to pallet molding on the ground. The molder places the stock board in front of him, sprinkles some sand on the inside of a mold or dips it into water, places it on the stock board. Dashes a lump of mud into it, presses it thoroughly, cuts any surplus mud with the strike, places appellate over the mold and turns it over. The molder then removes the mold by a jerk, leaving the brick on the pallet. A helper places another pallet on the brick so molded and carries it away to the drying ground where he makes the brick stand on edge. The pallets are thus available for use again. Although initial cost is little higher in table molding, it is considered more efficient. Machine molding. In advanced countries, machine molding is an essential part of the mechanized brick-making plants. It is both cheaper in the long run and gives bricks of uniformly good quality. There are two broad types of processes used in machine molding. First, stiff mud process and second, dry press process. Since we are fast progressing towards modernization in all sectors, it is appropriate to understand the basic principles of both the processes. Stiff mud process. The clay is mixed with only a small quantity, 8 to 12%, of water during tempering so that it is quite stiff in consistency. This stiff mix is then made to pass out under pressure from a molding machine. Two versions of molding machines used in the stiff mud process. The first type of molding machine consists of a feeding chamber provided with a worm gear to apply pressure. It has a hopper at the top to receive the clay mix. On the front narrow end, there is fixed a die of thickness and height of a brick. It is provided with a conveyor belt on a set of rollers and cutting wires adjusted in front of the die. For operating this machine, properly tempered stiff clay is fed into the chamber through the hopper. It is then forced forward using the worm gear. Under this pressure, the clay comes out through the die in the form of a continuous rectangular ribbon having the height and width of the bricks. It is then cut into brick lengths. This is done by allowing the ribbon to pass on the belt carrier from under the cutting wires adjusted for brick length distances. The lengths are cut either edgewise or sidewise depending on the orientation of the die in the machine. This machine can mold 1,000 to 2,000 units per hour. The second type of a brick molding machine is a vacuum press commonly used in USSR. Operation of such a machine is simple. The feed of properly mixed clay is supplied to the cylinder. It is then pushed into the vacuum chamber with the help of body screws through the perforated portion in the vacuum chamber. This mass is de-aired and then crushed by operating crusher. Thereafter, it is made to pass through the die by operating the crushing screw. It comes out from the die in the form of a continuous ribbon, which has the width and thickness dimensions of a brick. The brick lengths are then cut from this ribbon by using knives or wires. The main advantage of this type of vacuum machine is that de-airing of clay before pressing through the die results in bricks which are more denser and hence stronger. They are, therefore, least porous and most suited in places where moisture absorption by bricks is a common cause for deterioration of bricks. Dry press process. It is yet another common method for molding of bricks in mechanized brick manufacturing making plants. In this method, only a very small quantity of water is added to finely crushed and thoroughly cleaned clay, so that the resulting clay mix is not a plastic or stiff mud but just damp enough to take a shape under pressure. Such damp clay is fed through hoppers to special brick molds. This clay in each mold is then pressed hard through applinger using pressure in the range of 50 to 150 kg cm2. Such a pressure is sufficient enough to convert the loose damp clay mass into a dense, very compact brick unit, which is then removed from the mold. Such bricks are appropriately called pressed bricks, rather than molded bricks. They require practically little drying before burning. Moreover, they have perfect shapes on all the sides and edges and corners. Stage 4, Drying of bricks. After molding, the green bricks have to be dried. This is necessary for 3 reasons. Firstly, to make them strong enough for rough handling during subsequent stages, as for examples for stacking etc. Secondly, to allow a slow loss of moisture from the brick without disintegrating the unit. If a green brick is put to direct burning in a kiln, the rate of loss of moisture will be so fast that the brick will crack during the burning process. Thirdly, to save fuel during the burning stage, a brick containing 20% moisture will require more fuel to burn compared to a brick containing only 2 to 4% moisture. Drying of bricks is achieved either by natural methods or by artificial methods. In the natural drying method, there are two distinct stages. Pre-stacking stage. The artificial drying pre-stacking stage, where the molded bricks are first laid edgewise, sidewise and flat for 2 to 3 days so that they become hard enough to handle without losing shape or breaking. Stacking stage, in which the hard bricks from the first stage are arranged in well-made layers, one layer above another. Stacking in the manufacturing of bricks is done in specially prepared drying grounds. Each stack may be about 20 centimeters wide and as long as the ground allows. The height of the stack is generally of about 10 brick layers. Enough space is left between the individual bricks in a stack and also between the different layers for easy circulation of air. It is absolutely necessary that drying should be done in stacks that are properly protected from direct sun and rain. Air drying by staking may take 4 to 12 days for reducing the moisture to 2 to 4% in the brick. This depends on time and place of drying. The artificial drying. This method becomes essential in mechanized brick-making plants. It is only by this method that the drying of bricks can be ensured throughout the year independent of weather conditions. Artificial drying may be done either in specially designed chambers or in tunnels. In the chamber drying, bricks are arranged in stacks with sufficient spaces in between them for free circulation of air. Hot air under controlled conditions of temperature and humidity is made to circulate through these stacks for 2 to 3 days or more. The dried bricks are then taken out and next batch loaded in the chamber. In the tunnel dryers, the brick stacks are made on vehicles that travel on rails within a drying tunnel. The tunnel is divided into compartments and the stack-loaded vehicles is made to enter from one end, stay in each compartment for a prefixed time and come out of the other end. This process may again take 1 to 3 days for a carload of bricks to dry to a required moisture content. Use of sun-dried bricks. The sun-dried bricks, also called adobe, are poor man's construction material even during the present time in many countries of the world. These bricks, when protected from rain, are strong and durable enough to sustain loads of small units in villages. Stage 5. Cooling and burning of bricks. This stage of manufacturing of bricks is absolutely essential to develop in them the desired building properties such as sufficient strength, hardness, durability, and resistance to decay and disintegration. At least 3 chemical changes are known to take place in the brick earth during the burning process: dehydration, oxidation, and vitrification. Dehydration. It is completed within the temperature range of 425 to 750 degrees Celsius. Bricks heated to this temperature lose all the free water and most of the water of crystallization. Oxidation. It also starts within the above range or temperature and is completed at about 900 degrees C. All the organic matter in the brick earth gets oxidized, carbon and sulfur are eliminated as oxides. The fluxes, lime, magnesia, and iron, also become reactive at this temperature. The brick acquires the red color due to oxidation of iron in the clays. Vitrification is the extreme reaction that takes place from 900 degrees Celsius to 1100 degrees Celsius or so. The constituents of brick clay, that is alumina and clay, start softening in the presence of fluxes and getting bound together firmly. In fact, this is the change which makes a brick a strong and hard unit. But when the brick is heated to the extreme temperature of vitrification, the fluxes may actually cause considerable softening of the essential components of the brick earth. At that stage, the brick may lose even its original shape and get distorted at edges and corners. Hence ordinary, building bricks are not heated to very high vitrifying temperatures. Cooling. In this stage of manufacturing of bricks, the burnt bricks are placed for some time to be cooled before using it in the construction. Classification of bricks. Types of bricks used in masonry construction. Based on the manufacturing process, bricks are broadly classified into two types. 1. Sun-dried or unburnt bricks. 2. Burnt bricks. Sun-dried or unburnt clay bricks. Sun-dried or unburnt bricks are less durable and these are used for temporary structures. Unburnt bricks preparation involved in 3 steps. They are preparation of clay, molding, and drying. After molding, bricks are subjected to sunlight and dried using heat from sun. So, they are not that much strong and they also have less water resistance and less fire resistance. These bricks are not suitable for permanent structures. Burnt clay bricks. Burnt bricks are good quality bricks, but however they also consist some defected bricks. So, burnt bricks are classified into 4 types and they are: first class bricks, second class bricks, third class bricks, fourth class bricks, first class bricks. First class bricks are good quality bricks compared to other classes. They are molded by table molding and burnt in large kilns. So, these bricks contain standard shape, sharp edges, and smooth surfaces. They are more durable and having more strength. They can be used for permanent structures. However, because of their good properties they are costly than other classes. Second class bricks. Second class bricks are moderate quality bricks and they are molded by ground molding process. These bricks are also burnt in kilns. But because of ground molding, they do not have smooth surfaces as well as sharp edges. The shape of bricks also irregular due to unevenness in ground. These also will give best results in strength and durability. Smooth plastering is required on the brick structure. Third-class bricks. Third-class bricks are poor quality bricks which are generally used for temporary structures like unburnt bricks. These are not suitable for rainy areas. They are ground molded type bricks and burnt in clamps. The surface of this type of bricks are rough and they have unfair edges. Fourth-class bricks. Fourth-class bricks are very poor quality bricks and these are not used as bricks in the structure. They are crushed and used as aggregates in the manufacturing of concrete. They are obtained by overburning. Because of this they gets overheated and obtains brittle nature. So, they can break easily and not suitable for construction purpose. Categorizing bricks by raw materials. In modern construction practices, common bricks are categorized according to their component materials and method of manufacture. Under this classification, there are 5 common types. Burnt clay bricks, sand lime bricks, calcium silicate bricks, concrete bricks, fly ash clay bricks, fire brick, burnt clay bricks. Burnt clay bricks are the classic form of brick, created by pressing wet clay into molds, then drying, and firing them in kilns. This is a very old building material, the type of brick found in many of the ancient structures of the world. In appearance, these bricks are solid blocks of hardened clay, usually reddish in color. Burnt clay bricks are typically sold in 4 classes, with first class offering the best quality and most strength. These high-grade burnt clay bricks have no noticeable flaws, but they're also going to cost more. When these bricks are used in walls, they require plastering or rendering with mortar. Uses for burnt clay bricks include masonry walls, foundations, columns, sand lime bricks. Sand lime bricks, also known as calcium silicate bricks, are made by mixing sand, fly ash, and lime. Pigments may also be added for color. The mixture is then molded under pressure to form bricks. The materials bond together by a chemical reaction that occurs as the wet bricks dry under heat and pressure. These bricks are not, however, fired in kilns in the same manner as burnt clay bricks. Sand lime bricks can offer some advantages over clay bricks, such as their color appearance is gray instead of the regular reddish color. Their shape is uniform and presents a smoother finish that doesn't require plastering. These bricks offer excellent strength for load-bearing structures. When pigments are added, the bricks can be used for ornamental purposes. Less mortar is required during construction. Edges are straight and precise, making construction easier. Bricks do not effloresce salts and minerals. The uses for sand lime bricks include Structural foundations and walls. Exposed brick walls and pillars. Ornamental uses, when pigments are added. Concrete bricks. Concrete bricks are made from solid concrete and are growing in popularity among homeowners. Concrete bricks are usually placed in facades, fences, and provide an excellent aesthetic presence. These bricks can be manufactured to provide different colors if pigments are added during production. Concrete bricks should not be used in below-ground applications. Concrete bricks are manufacturing using concrete with ingredients as cement, sand, coarse aggregates, and water. These bricks can be manufactured in sizes as required. Common uses for concrete bricks include fences. Internal, hidden, brickwork. The advantages of using concrete bricks over clay bricks are that they can be manufactured at construction site, reduces quantity of mortar required, can be manufactured to provide different colors as pigmented during its production. Concrete bricks are used for construction of masonry and framed buildings, facades, fences, and provide an excellent aesthetic presence. Fly ash clay bricks. Fly ash clay bricks are manufactured with clay and fly ash, a byproduct of coal burning fired at about 1000 degrees Celsius. Because fly ash contains a high volume of calcium oxide, this type of brick is sometimes described as self-cementing, since it expands when exposed to moisture. This tendency to expand, however, can also produce pop-out failure. Fly ash clay brick has the advantage of being lighter in weight than clay or concrete brick. Typical uses for fly ash clay brick include structural walls, foundations, pillars. Anywhere that improved fire resistance is required. Fly ash bricks are manufactured using fly ash and water. These bricks have better properties than clay bricks and great resistant to freeze-thaw cycles. These bricks contains high concentration of calcium oxide, which is used in cement production. Thus it is also called as self-cementing brick. Fly ash bricks are lightweight and thus it reduces self-weight of structures. The advantages of fly ash bricks over clay bricks are that they have high fire insulation, high strength, uniform sizes for better joints and plaster, lower water penetration, does not require soaking before use in masonry construction. Fire bricks. Also known as refractory bricks, these are manufactured from specially formulated earth with a high aluminum oxide content. After burning, these bricks can withstand very high temperatures without their shape, size, or strength being affected. Common used for this type of brick include lining of chimneys and furnaces, pizza ovens and outdoor brick barbecues, engineering bricks. Engineering bricks have high compressive strength and are used special applications where strength, frost resistance, acid resistance, low porosity is required. These bricks are commonly used for basements where chemical or water attacks are prevalent and for damp-proof courses. Identification of bricks quality at construction site. Identification of bricks quality at construction site. To build a good quality structure, observing quality of materials is important. Here we discuss about how good bricks are identified at construction site. The color of bricks should be bright and uniform. They should be well burned and having smooth surfaces and sharp edges. Thermal conductivity of bricks should be less and they should be soundproof. They shouldn't absorb more than 20% by weight when we placed it in water. When we struck two bricks together, ringing sound should be delivered. Structure of bricks should be homogeneous and uniform. The bricks should not break when we dropped it from one height. There should not be any scratch left on the brick when we scratched with fingernail. There should not be any white deposits on brick when we soaked it in water for 24 hours. Lab tests on bricks. Types of tests on bricks for construction purpose. Following tests are conducted on bricks to determine its suitability for construction work. Absorption test. Crushing strength test. Hardness test. Shape and size. Color test. Soundness test. Structure of brick. Presence of soluble salts, efflorescence test. Absorption test on bricks. Absorption test is conducted on brick to find out the amount of moisture content absorbed by brick under extreme conditions. In this test, sample dry bricks are taken and weighed. After weighing, these bricks are placed in water with full immersing for a period of 24 hours. Then weigh the wet brick and note down its value. The difference between dry and wet brick weights will give the amount of water absorption. For a good quality brick, the amount of water absorption should not exceed 20% of weight of dry brick. Crushing strength or compressive strength test on bricks. Crushing strength of bricks is determined by placing brick in compression testing machine. After placing the brick in compression testing machine, apply load on it until brick breaks. Note down the value of failure load and find out the crushing strength value of brick. Minimum crushing strength of brick is 3.50 N/mm2. If it is less than 3.50 N/mm2, then it is not useful for construction purpose. Hardness test on bricks. A good brick should resist scratches against sharp things. So, for this test, a sharp tool or fingernail is used to make scratch on brick. If there is no scratch impression on brick, then it is said to be hard brick. Shape and size test on bricks. Shape and size of bricks are very important consideration. All bricks used for construction should be of same size. The shape of bricks should be purely rectangular with sharp edges. Standard brick size consists length breadth height as 19 cm x 9 cm x 9 cm. To perform this test, select 20 bricks randomly from brick group and stack them along its length, breadth, and height and compare. So, if all bricks similar size, then they are qualified for construction work. Color test of bricks. A good brick should possess bright and uniform color throughout its body. Soundness test of bricks. Soundness test of bricks shows the nature of bricks against sudden impact. In this test, 2 bricks are chosen randomly and struck with one another. Then sound produced should be clear bell ringing sound and brick should not break. Then it is said to be good brick. Soundness test of bricks. Structure of bricks. To know the structure of brick, pick one brick randomly from the group and break it. Observe the inner portion of brick clearly. It should be free from lumps and homogeneous. Efflorescence test on bricks. A good quality brick should not contain any soluble salts in it. If soluble salts are there, then it will cause efflorescence on brick surfaces. To know the presence of soluble salts in a brick, place it in a water bath for 24 hours and dry it in shade. After drying, observe the brick surface thoroughly. If there is any white or gray color deposits, then it contains soluble salts and not useful for construction. Properties of bricks. Properties of bricks. The essential properties of bricks may be conveniently discussed under the following 4 headings. Physical, mechanical, thermal and durability properties. Physical properties of bricks. These properties of bricks include shape, size, color, and density of a brick. Shape. The standard shape of an ideal brick is truly rectangular. It has well-defined and sharp edges. The surface of the bricks is regular and even. Special-purpose bricks may, however, be either cut or manufactured in various other shapes. These are generally modifications of rectangular shapes. Size. The size of brick used in construction varies from country to country and from place to place in the same country. In India, the recommended standard size of an ideal brick is 19 x 9 x 9 cm, which with mortar joint gives net dimensions of 20 x 10 x 10 cm. These dimensions have been found very convenient in handling and making. Quantity estimates 500 such bricks will be required for completing 1 m3 brick masonry. Color. The most common color of building bricks falls under the class red. It may vary from deep red to light red to buff and purple. Very dark shades of red indicate overburnt bricks, whereas yellow color is often indicative of underburning. Country. Length, cm. Thickness, cm. Height, cm. Standard size of brick in India. 19. 9. 9. Density. The density of bricks or weight per unit volume depends mostly on the type of clay used and the method of brick molding, soft mud, stiff mud, hard pressed, etc. In the case of standard bricks, density varies from 1600 kg cubic meter to 1900 kilograms cubic meter. A single brick, 19x9x9 centimeters, will weigh between 3.2 to 3.5 kilograms, depending upon its density. Mechanical brick properties. Under this heading of properties of bricks, compressive strength and flexure strength are included. Compressive strength of bricks. It is the most important property of bricks, especially when they are used in load-bearing walls. The compressive strength of a brick depends on the composition of the clay and degree of burning. It may vary from 35 kg cm2 to more than 200 kg cm2 in India. It is specified under the ISS codes that an ordinary type building brick must possess a minimum compressive strength of 35 kg cm2. The first and second class bricks shall have a compressive strength not less than 70 kg cm2 and 140 kg cm2 respectively. Flexure strength. Bricks are often used in situations where bending loads are possible in a building. As such, they should possess sufficient strength against transverse loads. It is specified that the flexural strength of a common building brick shall not be less than 10 kg cm2. Best grade bricks often possess flexural strength over 20 kg cm2. Similarly, it is required that a good building brick shall possess a shearing strength of 50 to 70 kg cm2. Thermal properties of building bricks. Besides being hard and strong, ideal bricks should also provide an adequate insulation against heat, cold, and noise. The heat and sound conductivity of bricks vary greatly with their density and porosity. Very dense and heavy bricks conduct heat and sound at a greater rate. They have, therefore, poor thermal and acoustic, sound, insulation qualities. For this reason, bricks should be so designed that they are light and strong and give adequate insulation. Durability. By durability of bricks, it is understood that the maximum time for which they remain unaltered and strong when used in construction. Experience has shown that properly manufactured bricks are among the most durable of man-made materials of construction. Their life can be counted in hundreds of years. The durability of bricks depends on some factors such as absorption value, frost resistance, and efflorescence. Absorption value. This property is related to the porosity of the brick. True porosity is defined as the ratio of the volume of pores to the gross volume of the sample of the substance. Apparent porosity, more often called absorption value or simply absorption, is the quantity of water absorbed by the brick, sample. This is expressed in percentage terms of the dry weight of the sample. Absorption equals W2 W1 W1 x 100, where W2 is weight after 24 hours of immersion in water and W1 is the oven dry weight of the sample. The absorption values of bricks vary greatly. It is, however, recommended that for first-class bricks, they shall not be greater than 20%, and for ordinary building bricks, not greater than 25%. The absorption characteristic of bricks affects their quality in many ways. Firstly, higher porosity means less solid materials, hence, strength is reduced. Secondly, higher absorption will lead to other water-related defects such as frost action and efflorescence. Thirdly, higher absorption results in deeper penetration of water, which becomes a source of dampness. Bricks are generally absorbs water but having limits. Absorption limit percentage by weight for different classes of bricks is tabulated below. Class of bricks. Water absorption percent by weight: heavy-duty bricks, special made, only 5%. First class, 20%. Second class, 22%. Third class, 25%. Frost resistance. Water on freezing expands by about 10% in volume and exerts a pressure on the order of 140 kg cm2. When bricks are used in cold climates, their decay due to this phenomenon of frost action may be a common process. This is especially so because bricks are quite porous materials. Apparent porosity equals 20–25%. It is, therefore, essential that bricks in these areas should be properly protected from rain to minimize absorption. Efflorescence. It is a common disfiguring and deteriorating process of bricks in hot and humid climates. Brick surface gets covered with white or gray-colored patches of salts. These salts are present in the original brick clay. When rainwater penetrates into the bricks, the salts get easily dissolved. After the rains, evaporation starts. The salts move out along with the water and form thin incrustations on the surface of the bricks. Salts which are commonly precipitated during efflorescence are sulfates of calcium, magnesium, sodium, and potassium. It is why great emphasis should be laid while testing the chemical composition of the clay for brick manufacturing. Summary: properties of bricks. It should have a rectangular shape, regular surface and red-colored appearance. It should have a rectangular shape, regular surface and red-colored appearance. It should be properly burnt. This can be ascertained by holding two bricks freely, one in each hand, and striking them. A sharp metallic sound indicates good burning, whereas a dull thud would indicate incomplete burning. A good building brick should not absorb water more than 20% of its dry weight. Absorption should not exceed 25% in any case. A good building brick should possess requisite compressive strength, which in no case should be less than 35 kg cm2. A rough test for the strength of the brick is to let it fall freely from a height of about 1 meter onto a hard floor. It should not break. Brick should be hard enough so that it is not scratched by a fingernail. A good brick has uniform color and structure through its body. This can be checked by taking a brick from the lot and breaking it into two parts. The broken surface in both the halves should have same appearance and structure. Compressive strength of bricks. Compressive strength or crushing strength is the property of brick which represent the amount of load carried by brick per unit area. According to BIS, the minimum compressive strength of brick should be 3.5 N/mm2. Crushing strength of bricks reduced when they are soaked in water. Crushing strength of bricks. Grades: 714 N/mm2. Class A 14 N/mm2. Class A. Types of brick bonds. Most popular types of brick bonds. Brick walls can be structural, like load-bearing walls, or they can also be primarily decorative, like a brick veneer wall. Structural walls demand solid structural bonds, while decorative walls can use any bond pattern. Let's take a look at some of the most traditional and popular brick bonds used for walls. Stretcher bond, running bond, header bond, English bond, Flemish bond, stack bond, Dutch bond, common bond, American bond, facing bond, diagonal bond, rat trap bond, stretcher bond, running bond. One of the most common brick bonds, also popularly called running bonds. This bond is very easy to lay, in fact, is one of the simplest ones used today. Stretcher bond is suitable when walls of half brick thickness need to be constructed. Different types of wall construction done using this kind of bond are sleeper walls, partition walls, division walls, internal dividers, chimney stacks. Stretcher bonds are not very suitable for standalone structural walls, but very useful for construction of walls with less thickness. Note: this bond will fail if the thickness of the walls is more than half of the total length of the brick used. Header bond. A header is the shorter face of the brick. In header bond brick masonry, all bricks are constructed in the header course. In this bond, the overlap is performed corresponding to a half width of the bricks. The 3/4 brick bats are utilized in alternative courses as coins. This bond is mainly used for the construction of 1 brick thick walls. English bond. One of the most commonly utilized variations of brick bonds in masonry works. This bond essentially comprises of alternating courses of headers and stretchers. Headers are laid centered over the stretchers in the course below, and each alternate row is vertically aligned. To break the continuousness of vertical joints, a coin closer is used at the start and end of a wall after the first header. A coin close is a brick that is cut lengthwise into 2 halves and used in the corners in brick walls. This type of bond is mainly used to construct strong 1 brick thickness walls. Flemish bond. For this type of bond, each course is made up of alternate headers and stretchers. Each header is centered on a stretcher above and below, and every alternate course begins with a header in the corner. For breaking the vertical joints in the successive courses, coin closers are introduced in alternate courses next to the header. This bond can be significantly subdivided into 2 diverse types. Single Flemish bond, a combination of English bond and Flemish bond. The front exposed surface of the wall is composed of Flemish bond and the back surface is composed of English bond in every single course. Double Flemish bond. This bond takes a similar appearance both in the front and the back elevations. Walls with Flemish bond are complex to erect and demand greater skills. Stack bond. In a stack bond, all the bricks are plainly loaded on top of each other and held with mortar where all bonds are perfectly aligned. Because of its weak masonry structure and less strength, stack bonds are perfect for decorative purposes. This bond is a non-structural bond, hence not suitable for walls which require to transfer loads. Dutch bond. A modified form of the English cross bond which consists of alternate courses of headers and stretchers. In this arrangement of the brick bond, every single stretching course begins at a coin with a 3/4 bat. Every alternate stretching course has a header set next to the 3/4 bat brick provided at the coin. This bond is perfect to construct strong corners along the wall which are subjected to excess loads. Common bond. American bond. This bond is very similar to the English bond, but this one has courses of headers inserted in every 5 or 6 courses. Header courses are centered with the previous header course. This header bond basically acts as a tie brick between the fronting and the backing. To achieve the sufficient offset in a standard common bond, queen closers are inserted at both ends of the header courses. The common bond is normally used in exterior load-bearing walls. Facing bond. This bond is primarily adopted for thick walls, where the facing and backing are chosen to be constructed with bricks of diverse thickness. Typically, this bond consists of heading and stretching courses arranged in a manner that one heading course comes after quite a lot of stretching courses. The load distribution of walls using this bond is not uniform because of the difference between the facing and the total number of joints in the backing. This can also lead to unequal settlement of the thickness of the wall. Diagonal bond. Best suited for walls of 2 to 4 brick thickness. This bond is normally introduced at every 5th or 7th course along the height of the wall. Bricks in this bond are placed end to end in such a manner that extreme corners of the sequence remain in contact with the stretchers. Rat trap bond. In this bond, bricks are laid on edge or placed in a vertical position instead of the conventional horizontal position. This creates a cavity, hollow space, within the wall. This feature helps in keeping enhanced thermal comfort and keep the interiors cooler than the outside and vice versa. This type of walls consumes a smaller number of materials due to the internal cavity. The rat trap bond looks very similar to the Flemish bond in appearance. Skilled labor and extra care are needed to design this bond. Common paving brick bonds. Few of the most common paving brick bonds are running bond, same pattern as the wall brick, but these can be done parallel, vertical, or diagonal to the length of apathy or patio. Herringbone bond, this is one universally attractive pattern. A very simple zigzag pattern where each brick is perpendicular to its neighbors. Basket weave bond, a square pattern with bricks placed side by side in pairs, and each pair is perpendicular to its neighbors. This is an easy pattern for areas that are rectangular or square in shape. Stacked bond, also known as jack-on-jack paving. This is a square grid of even rows with no staggering between courses. Uses of brick. Brick plays very important role in the field of civil engineering construction. Bricks are used as an alternative of stones in construction purpose. Here some main uses of construction brick are given below. Construction of walls of any size. Construction of floors. Construction of arches and cornices. Construction of brick retaining wall. Making koa, broken bricks of required size, to use as an aggregate in concrete. Manufacture of cirque, powdered bricks, to be used in lime plaster and lime concrete. Advantages of brick construction. There are many advantages when bricks are used as part of the construction. Aesthetic, bricks offer natural and a variety of colors, including various textures. Strength, bricks offer excellent high compressive strength. Porosity, the ability to release and absorb moisture is one of the most important and useful properties of bricks, regulating temperatures and humidity inside structures. Fire protection, when prepared properly, a brick structure can give a fire protection maximum rating of 6 hours. Sound attenuation, the brick sound insulation is normally 45 decibels for a 4.5 inches brick thickness and 50 decibels for a 9-inch thick brick. Insulation, bricks can exhibit above normal thermal insulation when compared to other building materials. Bricks can help regulate and maintain constant interior temperatures of a structure due to their ability to absorb and slowly release heat. In this way, bricks can produce significant energy savings, more than 30% when compared to wood construction. Wear resistance. A brick is so strong that its composition provides excellent wear resistance when compared to wood. Disadvantages of bricks. Time-consuming construction. Cannot be used in high seismic zones. Since bricks absorb water easily, therefore, it causes fluorescence when not exposed to air. Very less tensile strength. Rough surfaces of bricks may cause mold growth if not properly cleaned. Cleaning brick surfaces is a hard job. Color of low-quality brick changes when exposed to sun for a long period of time.
Thank you for watching. Please subscribe to the channel and press the bell icon.